We're going to start in 1 minute, so please take your seats. Good morning. I am so thrilled to be joining you here this morning at our third annual Day of AI celebration at this incredible Museum of Science, Boston. I especially want to welcome the teachers and students from the New England Innovation Academy who are joining here today. Woo-hoo! And our supporters of Day of AI and our online audience. So we hope you really have an amazing, thought-provoking, really fun time here today with us. My name is Cynthia Brazil. I'm a professor at the MIT Media Lab. I'm also the MIT Dean for Digital Learning, and I'm the director of RAISE, the MIT RAISE initiative. And RAISE stands for Responsible AI for Social Empowerment and Education, and we are the initiative that puts on the Day of AI program every year. So we live in interesting times. AI is changing everything. And we believe that AI is for everyone. Our mission at RAISE is to prepare students everywhere, students like you, to be successful, to be happy, to be prosperous in an increasingly AI-powered world where we want you to also be empowered to shape that world. And that's why we developed the Day of AI program as well as other programs at RAISE. Today is our annual day of global sharing. We say any day is a day of AI. Teachers can offer the Day of AI anytime during the academic year, but this is really the day we come together and acknowledge and celebrate all the amazing projects and activities that students do around the world. And you're all a part of it, and you're all part of it. All right, so over 10,000 teachers, educators, and mentors from over 110 countries around the world do the Day of AI. So this is really becoming a global movement where it's all about bringing AI literacy to classrooms, after-school programs, you name it. So clearly the world is very curious about AI. And we want to help educate an AI literate world because AI is transforming what it means to be digitally literate and a digital citizen. We want you to understand how AI actually works. We want you to be informed users of AI technologies and tools. We want you to be able to express yourselves creatively, to use AI to solve problems with critical thinking skills, and to understand the potential benefits and harms it can bring. So we want you to have an ethical and responsible way to think about this really powerful, cool, and exciting technology, but something that really needs to be done responsibly. And again, we want to empower you to know that this is a tool that you can use to make your community better, to help people around you with this technology. So to help achieve this goal, we and our collaborators have developed a whole series of short format curriculum, kindergarten through high school, with lots of hands-on learning, creative problem solving, creative expression, critical thinking, to really help you and your teachers understand a bit more, again, about how AI works, how it's transforming what it means to be a digital citizen today. We add new topics every year that are particularly relevant to students. For instance, we have lessons on ChatGPT and generative AI, AI in policy, the use of AI in video games and social media, and so much more. And this year, we announced a new curriculum on data science and climate. So, you know, when we wanted to, when we wanted to host our activity, our Day of AI annual celebration today, we wanted to highlight the theme of AI, data science, and climate. And we couldn't think of a better venue to do that here than the fabulous Museum of Science in Boston, given their shared educational mission, both in educating the general public in AI and climate and sustainability. So really, it was perfect of how all of these things came together. So we have an amazing program here for you today. We're going to hear from incredible presenters here at the MIT Media Lab, at NASA, at the Boston Mayor's Office, and here at the Museum of Science. We're also going to hear some amazing presentations from students from the New England Innovation Academy. Woo! All right. And we know you've been working really hard on these projects, and we're super excited to hear about how you've been learning about generative AI and data science to model and make predictions about climate-related phenomena, right? Super cool. All right. So I just want to give a big shout out to the MIT App Inventor team, and especially Robert Parks and Salim Tenzel, who helped design this particular module that the students will be presenting today. Woo-hoo! Along with Francisco Morales and Lily Fu from the New England Innovation Academy for really helping to facilitate the student activity. We're also going to hear an exciting announcement from the App Inventor Foundation. So to wrap it up, we're going to have students be able to also look at the museum, explore the exhibits as well. So really, this is going to be a fun-filled day. So I hope you learn a lot. I hope you really have a great time. And again, we want you to feel empowered that you can make a difference with AI. So here we go. Before I introduce the next speaker, please join me in a round of applause to thank the Museum of Science for welcoming and hosting us today, MIT Ray's faculty, staff, and students, and our friends at i2 Learning for their hard work in bringing Day of AI to the world. Special shout out to Maricel Diaz and Steve Nelson from MIT Ray's in organizing this activity with our Museum of Science collaborators. And we very much appreciate the generous support of our Day of AI sponsors. This Day of AI celebration wouldn't be possible with all of you. And with that, I'd now like to hand it over to Tim Ritchie, who is the president of the Museum of Science.
Thank you, Cynthia. We are so honored to have you all here today. And to everybody who's online, we're honored to have you as well. I first want to say thank you to the teachers of the Innovation Academy and to teachers all over, 10,000 teachers, did I hear that, around who are making this happen. Thank you for your good work. Please give a round of applause to the teachers. And then my comments are now directly to the students who are online and to the students here. I think what's amazing is that none of us can fully understand how awesome the world is. But what's amazing about being a human is we've been given the possibility to understand it. And AI gives us a chance to do that. And it is far more awesome, far more full of answers than we can even imagine. And that's a striking and amazing thing to face, because there are 8 billion people on the planet. 8 billion people on the planet. And all 8 billion of us want the same things. We want access to good jobs and to good food and to peace and security. And that is not the human experience right now. For most people, that's not. And it's going to be your job and your ability to make that more of the reality than it is right now. And AI will be the necessary thing that helps you do it. Without it, we will not be able to live sustainably and humanely on Earth. But with it, we can. So when you think about the Earth, when you think about what we're facing with climate change and with 8 billion people, and then you think about yourselves, what I'd say is, it's amazing that you at such a young age are already using this great tool. The world really literally will belong to you. It will belong to the young people who can understand and use science and technology. So congratulations for being here. Aim high, do good, make the world better. I know you can do it, and I just wish you all the luck in the world. So thank you very much. I'm not quite sure who's next, Cynthia. Oh, okay.
Great. Thank you so much. All right, so now our next speaker is Michael Lawrence Evans, who is Director of Emerging Technology at the City of Boston.
Hi there. I'm just going to get the clicker. Okay. So thank you, Professor Brazil, and thank you to President Tim Ritchie. It's such an honor to be here today. So I'm Michael from the Office of Emerging Technology, and it's at the City of Boston, and what we do is we plan the exploration and adoption of new technology to improve city services at the city. But today I'm going to talk to you about climate change and artificial intelligence. And we all know that the buildup of greenhouse gases like carbon dioxide is driving climate change. So I'm going to tell you about one way that we're reducing our carbon footprint, and later on how we're preparing for a more volatile climate, including ways that AI can both help and potentially hurt in that effort. Okay, so how are we reducing our carbon footprint in Boston? With a cutting edge technology called the bicycle. And so it was invented in 1817, at least according to Wikipedia. But the city's putting a lot of effort into making biking more accessible for people. And one reason for that is that 65% of transportation emissions are from cars. So there's a really big opportunity to switch to other modes of travel like bikes. And so this is a carbon calculator on the web that kind of shows the obvious. You can, what the carbon calculator is showing is a trip from Boston City Hall to the Museum of Science, and basically you can save over 90% of the carbon emissions by taking a bike versus a small car. And cities like Boston and Cambridge have made it a lot easier to bike in Boston. We have Blue Bikes, which is our bike share system, and anyone can check out one of 4,000 bikes at 400 stations across 13 cities and towns. Here's a map of our bike share system. It's really extensive. And here's where we are at the Museum of Science. And you can see that if you were to check out a bike just right outside the entrance of the museum, there's 6 available bikes, including an electric bike, which is actually really fun to ride. So now, let's move on to how the city is preparing for a changing climate. Much of that revolves around water, and basically with climate change, there's going to be more floods, there's going to be more droughts due to extreme heat, and in a few minutes we'll see how there's a surprising link between water and artificial intelligence. So environmental planners at the city are using data and AI-enabled climate modeling to forecast potential floods well into the future. This helps us plan how we're going to protect our neighborhoods. And in partnership with the Stone Living Lab, they have installed a network of sensors that monitor water levels along our coastline. We can use this data to improve short-term flood forecasts with AI and create an early warning system so we're more prepared for flood emergencies. But we also need to be mindful of the environmental impact of AI. This is a data center which stores and processes enormous amounts of information, much of it available on the internet, like your favorite videos or your favorite online video games. Sorry, I went ahead too much. And so the AI models that form the basis of services like ChatGPT and other chatbots that you might that you might try on the web get trained in data centers. And the computer systems creating these models perform a staggering number of calculations, trillions per second. And these systems consume a lot of power, give off a lot of heat, and need to be constantly cooled down. So how do they keep the data centers cool? Essentially, data centers use an intricate system of pipes and coils to run cool water through their facility. When the water flows towards areas of hot equipment, the heat from the air transfers to the water, which is then carried to a cooling tower on top of the data center. You can see the little steam clouds just kind of like chilling, above the data center. So why would we care about this, and what's the connection to climate change? The answer is that climate change is going to cause more droughts. And some data centers use close to 500,000 gallons of water every day, and could add to significant stress to local water systems. And here's a map of current drought conditions across the country. This is updated from last week. And the areas in red are dry, and the areas in blue are wet. And you can see in our region in New England, we're doing okay right now. We're generally in the blue, but this was not always the case. This is a drought map from 2 years ago during the summer of 2022, and you can see in New England in the upper right-hand corner, we were experiencing an extreme drought. So it's not like we're in other areas of the country where they're constantly in drought conditions. I think we just always need to be mindful that we just always need to be mindful that we could, even though things look okay now, we can always end up in a drought condition. And so, this century, climate change is going to make things pretty tricky. And historically wet areas could experience, more rain and flooding, and historically dry areas, less rain and more droughts. And there's an important role for technology to help manage these issues, but we need to be mindful of their environmental impact. You are all leaders of the future, and you'll be grappling with these issues, finding the right balance, and helping us innovate by thinking creatively and keeping an open mind. And I just really appreciate you all taking the time to listen to my little talk today, and thanks so much.
All right, thank you, Michael. All right, our next speaker is Dr. Rachel Connolly. She is a research scientist at the MIT Media Lab, and she is the Systems Integration and Analysis Lead for NASA's Science Activation Program. All right, welcome, Rachel.
Thank you. Hi, everybody. I used to teach high school in New York City, so any opportunity to get to talk to students is wonderful. So thank you so much. So I was asked to talk about why STEM matters, but why something matters is very personal to everybody, depending on where you are. So I'm going to take a different approach and talk about what STEM is and what it really looks like when it's done well and together. And then hopefully you'll come away with why it matters to you. So let me get started. STEM stands for science, technology, engineering, and math, which are all by themselves really big concepts. I mean, you probably took classes in each one of these things. But when you mush it all together, why do we mush it all together? And what does it look like when that's done really well? So, if you know what this is, say it out loud. Okay, so great, awesome. So most of you know that this is Saturn, and as you said, you know that this is probably a planet in our solar system. But this is what Saturn has looked like over the years. This is what 400 years of Saturn looks like, based on the best data available at the time. And that first drawing was made possible when Galileo pointed the first telescope at that dot in the sky and said, why does it have ears? And then why it has ears became, oh, it has rings. And then, oh, it has rings became, what are they made of? And so on and so forth. So those scientific questions evolved. But you can see how the telescopes and the engineers and technicians that designed them and invented them really advanced the questions and what we were able to understand about the things. So you can sort of see how this dance works together of science and technology and engineering and math working together to really advance knowledge and understanding. Now, let's take a look at this last Cassini space probe that actually took a death dive into Saturn in your lifetime. This is the team of over 1,000 people that were behind this $3+ billion mission. And when you really look at all of these people, you see you have software designers and mechanical engineers and planetary scientists and data analysts who are mathematicians, that all of them had to come together to create this machine that really gave us this amazing new understanding about Saturn and the Saturn system. And so where are we now? What does that look like? So this is what all that information together in a computer model that can be run as a simulation allows us to see dynamic, even things you can't see with the naked eye, like the magnetic field lines and the moons. So this is how STEM advances what we know about a phenomena or an object, in this case Saturn. But why stop there? So who here plays video games? Okay, that's a lot of you. For the people in the audience, or people who are not here, a lot of people raise their hands. So if you've been in a virtual world, if you played in Minecraft and that, you understand that we can build virtual worlds. But when we put all of our data together, we can do this for the universe as well. And I can now take you on a journey from the Earth to the edge of the observable universe with just data, authentic data we've collected. So we're going to leave the Earth here. You can see how it looks, how beautiful it looks with the blues and the greens and the vegetation and the clouds. That is what it looks like from space, our planet. And as we pull away, you can see the stars in the background. Some of the distant stars that make up constellations. You might notice that Orion is over there. And what do you think the first thing that we're going to pass is after the Earth? You guys can say. The moon. Here we go. Past the moon, 250,000 miles away, or 1 light second from us. And as we pull away, you can start to see the orbits of the rest of the inner solar system and how they're all flat because of the way we formed out of a disk of material. And then what do you think we're going to see next? The millions of asteroids, large and small, that we know of and track. For safety, too. You really need to know where they are and how they're moving. The Kuiper Belt objects, where the comets come. And as we pull out of our solar system, these are the furthest Voyager spacecraft that have left our solar system. That is our physical extent as humans in space. And now we're in interstellar space. And as we move out into interstellar space, soon we're going to pass our radio bubble. When we started broadcasting radio in about 1905, that's a ripple in a pond that's moving outward at the speed of light. And when we pass that in space, nobody outside of that bubble has heard us or even knows humans exist yet. There we are. And then we have about 5,000 exoplanets we know about, and the ones that are inside the bubble, they've heard us, if they're listening. And maybe they've responded. We just don't know yet. But now, that bubble is the extent of humanity in the universe, in our reach. And now you can start to see, as we pull out the dust and gas of the arm of our galaxy, the Milky Way. And pretty soon, you'll start to see all the other dots around us are all other galaxies. Not other stars, other galaxies. Each with 100 billion stars or so in them. And now this is where you really can start to see how our data collection and our technology is impacting what we know. You can see slices and areas where we've got more galaxies and areas we cannot observe because we can't see through the gas and dust. see here, you can actually start to see how the northern hemisphere and the southern hemisphere observations give us more and less data. And then there's the gap in the middle where we don't yet have data. We're building our universe through STEM, and this is what it looks like. Now we have, at the distance, quasars are early galaxy cores, quasi-stellar radio sources, and now we bring up the oldest light we can detect, the cosmic microwave background radiation. This is the leftover energy from the Big Bang, and we can still observe it. It's the oldest thing we can see. So, this is what we can do now because we've built the data. And this works at home too. In fact, we have over 9,000 satellites right now going around our planet, and about 1,000 or so of them are just Earth-observing satellites. This is just some of them in what we call the Earth Fleet from NASA. You can actually see SMAP, that's the soil moisture probe that actually just looks at the soil moisture for things like crops and food and that, very important things to us. So all of these Earth-observing satellites come together, gather data. This is what 6 hours of data collection looks like. A terabyte of data a day, actually terabytes. I think about 3 terabytes a day are gathered. And in 6 hours, you could sort of see how the different kinds of data collection, there's things that globally map, there's things that are regional, sensor networks. They get downloaded every 6 hours and integrated, and our models are updated. And this is how we really keep on top of really important things about our planet, like the wind and currents, ocean currents, and you can see how the heat is distributed to the poles and keeps us from freezing in Northern Europe. The biosphere shows us seasonal changes, things like that. The beauty of the planet is getting more and more visible and accessible, and AI is only going to give us new insights into how these things are connected. So, we live on that planet and we have challenges that we face. These are what are called the grand challenges. These are the engineering grand challenges in areas of sustainability, health, security, and enriching life, or joy, bringing joy. If you can look at these and find something that's interesting or connected to you, you can really see how STEM, all of the pieces, are really important to making all of these challenges something that we can work on together. Things like the nitrogen cycle and solar energy, understanding the brain, and all of that. So, if something here matters to you, then STEM is an important part of your life, I hope. So I've left you with this. If you scan this, if you want, this will bring up something on your phone that's called Earth Null School. It looks like this, and it lets you zoom in, look at different data sets on the Earth. So I hope to leave you with a little bit of Earth data in your pocket, and thank you for your time. So.
All right, that was amazing. All right, our next speaker is Deva Newman. She is the director of the MIT Media Lab and is professor of the Aeroastro department at MIT.
Thank you. Hi, everyone. How you doing? Great. We're gonna kind of keep some of this STEM, but I call it STEAMed, because it's not just about science, technology, engineering, math, but it's also about bringing in the artists, the storytellers, and it's about the designers, all of you, the 3D makers out there. So let's continue on this amazing journey that Dr. Conley shared with us. So in all of exploration, we have these 3 fundamental questions, okay? Exploring that universe. It says, are we alone? I don't know. What about habitable planets, those exoplanets? The evidence is mounting. They might be habitable. And then when will we find life? When will we find life elsewhere in the universe? It might be past life or present life, but these are these fundamental, huge questions. You're taking a look at the Westerland 2 cluster. And in the 10 seconds you're seeing this animation, 3,000 new stars have been formed. 3,000. So, gosh, it's almost infinite. It's just even hard to think at this scale, right? But so exciting about all of the questions you have, all the work we can do in exploration and discovery. And it's all about making life here better on Earth. So this is our James Webb Space Telescope. How many people know about Webb? Yep. A lot of hands went up. That's fantastic. What is it doing? We couple it with Hubble. Hubble is an optical telescope. Webb is now looking at the infrared. And take a look at the difference. This is the pillars of creation. You might know M16, its technical name. Hubble image on the right. And now look at that. We can see what was previously visible. So we can imagine what's visible. So look at that. That's discovery. That's the tour that Dr. Connolly took you through, just to think big and bold and imagine how much more we have to discover, how much more we have to explore. So finding life, searching for life in the universe, carbon-based life, we say follow the water, right? It worked out pretty well here on Earth. So where else might have life? I love this picture because these are ocean worlds. These are moons of many of our planets just here in the solar system. Enceladus, it's around Saturn. That's to scale. So it looks very small, but it's spewing hydrocarbons, hydrogen, sulfur. It's kind of like if you've ever been to Yellowstone National Park and saw Old Faithful spewing that. So it's like a chemistry lab. Maybe there's life there underneath its ice. Europa, now that's a moon of Jupiter. Again, an icy ocean world. We know it has water, so we need to go there. We need to go there with our scientific probes, take that data back. Maybe we'll find the evidence of life. So thinking very vast, but I want to come a little closer to home now and quickly touch on Mars, Moon, and the Earth, because all of our exploring is for humanity. It helps us become hopefully better and better stewards here of spaceship Earth. So this is to scale. That's Earth, the beautiful blue planet. Mars is half the size of Earth and might have the evidence of past life. And then there's, of course, our glorious moon. So Mars is not option B. We're going to go there as explorers and find out if it ever had life, but we need to protect our planet right here on Earth. Well, we have been on Mars for 50 years. How many of you saw The Martian? All right. This is a great audience, a fun, interactive audience. We at MIT, our experiment was MOXIE. We made oxygen. We made oxygen out of the carbon dioxide atmosphere, the 1% carbon dioxide atmosphere of Mars. Why? First, maybe for propulsion. When we send humans there, we need our fuel. We need our fuel to return home. It's a round trip. It also would be great in a spacesuit to help you breathe and live when you're there. So that's why we're trying to make oxygen, on another planet. And I wanted to show you this this little video here because we use augmented reality. Put you in a headset. Every morning when we wake up, because we have the rover on Mars today, we actually, our mission planners, folks that work in STEM, the folks at NASA, Jet Propulsion Lab, the university folks, they get in their headset and basically they're seeing the image of Mars, so it's really enhancing their science. And they're working as a team. You have your avatar, so the three of you can talk to each other and say, where are we going to do today? What science are we going to do today? So the technology and our AI algorithms to kind of crunch all that data that Rachel was talking about is really enhancing the science we can do, not just on Earth, but even off planet. Okay. Let's zoom into the moon. We're going back to the moon at MIT. I am the Apollo program professor, and this year we have a mission. It's going to look like that. It's a vehicle, but we're preparing. We're getting in the data, and we're running training for astronauts of the future, training for students. This is all open source, so you can have access to our lunar mission control to explore the South Pole. How much water is on the moon? We don't know. So we have to explore that. And here on Earth, we go out into the field. We go to the Arctic or Antarctica to run simulations, to test our technology, to go through the entire mission. We have been to the moon before. Oh, you can have sound. You know what this is?
Smith having a few problems.
That's when we sent astronauts to the moon the first time during Apollo. It was really hard. It was really hard to work in that spacesuit. It's a big balloon. It's a big gas pressurized shell that we put around the astronauts. So we didn't let them do much science, right? We kept them alive, which was fantastic, but it really kind of was hard to it was really hard to be mobile. It was really hard to get those scientific samples. Okay, well, this is what the current spacesuit looks like today. It's a big, bulky, gas pressurized shell, keeps you alive. I call it the world's smallest spacecraft. We take all of the systems of a spacecraft and we shrink them around the person to keep you alive, give you oxygen, scrub out the carbon dioxide. But it weighs about 160 kilos. That's almost 300 pounds. So this is a big, heavy craft. So we have to do something different. So what we do in terms of designs, we want to do a skin suit. Apply the pressure directly to your skin, make you very, very mobile. We think that's a big technology push that might help you become interplanetary. Next stop is getting people safely to the moon. Again, doing our science there, and then the long-term goal is to get humans to Mars in the coming decades. But now, I want to take you right here to Earth. We're neighbors here from the MIT Media Lab. And again, we all do STEM education. I call it STEAM. Let's bring in the artists, the storytellers, the visionaries, the historians, and let's design it. We love to prototype, right? We're prototyping our future. If you can think of it, it's a big challenge, as Rachel put up, then we can prototype it and design it. So that's what we do, is kind of thinking about how we can reimagine and redesign people's lives here. So we work across these big areas, life with AI. Today we're here to celebrate with you, amazing day of AI. So AI and the human experience. How do we enhance the human experience and lift you all up? Searching for life in the universe, future worlds, and just galvanizing a whole revolution of creativity. How can we be more creative than we want to? Rachel showed a little bit of what I call the vital signs. How is Earth doing? Earth is breathing, living, being, and talking to us. She showed you the constellations of satellites that we have. And again, just another look at what they're measuring. Let's take a look maybe at temperature here, okay? This is the world's history of global temperature. From the 1800s, 1900s, you can raise your hand when you're born, okay? It's gonna go all the way up to present day. Blue is 1 to 2 degrees Celsius below a running mean, and yellow and orange are 1 to 2 degrees above that mean. 2 degrees Celsius, we're approaching that. We're at 1.17 today. Take a look. 2000, thank you, 2010, some of you are born right there. It's hot, right? This is the scientific data. We curate it, we share it with people, it's all open source. Here's the same data over the last 6 decades, and you're seeing this anomaly, and you see how hot it is. 2023 just set all records for the hottest year, most of the hottest months. Okay, but what can we do about it? We do have to change behavior. What can we do about it, okay? We can make things better for humanity. So the big idea then, kind of to leave you with and show you a little bit more, is what happens if we had an Earth embassy, right? Earth needs a mission control. Maybe Earth didn't come with an operating manual. Maybe that's what we got wrong. What if we could have an operating manual, like our computer systems, is everything working? How can we have Earth work for all of humanity and all of living things? So we think about that in terms of what's the AI platform, that operating system for Earth? How do we engage all of you? You're our Earth ambassadors. So training and education, AI education for all of you, as you're really the Earth ambassadors. And we need to help you so that you can help all of us. So it's a very urgent cause, but we're very optimistic. There's so much we can do. There's so much we can do if we do this all together. And this is a little video that I want to end on in terms of virtual reality. We were here just 2 weeks ago at the museum at this Earth Mission Control to bring all that space data right down to home so that you can access see the Earth in all of its glory and beauty. And then there's these dashboards. What data are you interested in? Maybe carbon dioxide, maybe it's ocean data. Maybe it's looking at the methane. So giving you the option in these dashboards to take a look at the data that you want. It's probably Boston. Maybe you're interested in flooding. Again, there's the Earth observing satellites. As Rachel mentioned, with all of our thousands of satellites, we have hundreds of terabytes of data, but it's available to you. We open source it. We need to use a lot of machine learning and AI algorithms to get a handle on this data. It's all training data. It's all very scientifically verified and trusted. And then immerse people in what the conditions are on Earth right now. And then at the end, the best part about all of this is that you can take action. You can ride that bike, as we heard about earlier. You can help with diet and things like that. So everyone can do a lot. There's a whole bunch of actions we can take every day for this, beautiful, beautiful spaceship Earth that we inhabit. And AI is really going to help you accomplish all your goals and reach, attack and address those challenges that you're most interested in. So I think there we go. I just, one last thought. This is from Bucky Fuller. The goal, I think, for all of us then is to make the world work for 100% of humanity, and I would add all living things. Now, we have to do this in the shortest possible time, but I'm so excited because I think through spontaneous actions from all of us, 8 billion people, if we all do this just a little bit, if we all do that together, I'm very optimistic that we have a bright future for all of us. So thank you so much for your attention.
Great, thank you, Deva. I love that idea of Earth ambassadors. All right, now I'd like to welcome to the stage David Sittenfeld. He's the director of the Center for the Environment here at the Museum of Science.
Thank you so much, Dr. Brazil. What an interesting couple of presentations there to help us understand the relationship between artificial intelligence, our climate, our environment, and our future. As was just said, my name is David Sittenfeld. I'm the director for the Center for the Environment here at the museum. And my job is to facilitate a conversation with two really interesting human beings about what it's like to learn about these topics in a setting like your school or the Museum of Science. And we're going to talk a little bit about that over the next couple of minutes. Before I do that and bring up our speakers, I thought I'd just kind of do a little bit more in building on what we just heard from some of the speakers about the connections between artificial intelligence and our environment. I took a quick walk over to the Exploring AI exhibit that I know some of you will be exploring in just a few minutes, and I found 4 examples of intersections between our environment and artificial intelligence just in that exhibit. One is that artificial intelligence can help us identify where plastic waste might be in the ocean or on the land in a way that people just would not be able to do by themselves. Another example is there are autonomous tractors in there that can drive a little bit more efficiently, save a little bit more fuel, a little bit more electricity so that they can work a little bit better. Another example is better agricultural practices. We heard from Michael at the beginning about farming and how this is such an important thing for us to be able to do efficiently. And then finally, a very topical and relevant example is that AI can actually help us spot wildfires when they're just starting so that we can put them out better. And if you've been listening to the news this morning, you might know that unfortunately this is the time of the year that the Canadian wildfires begin in the spring. You might remember last year we had all that awful smoke that affected people across the country, especially people who may have asthma or other kinds of conditions. So anything that we can use technology to help us spot these things helps us address them better. Those are examples of where AI kind of tells us what to do, right? It tells us what we can do faster. But then there are these examples where AI can help us understand that there's a problem, but it doesn't really tell us what to do or how to do it in a way that we know will make the world a better place. And that is where people and AI will need to coexist in a way that really makes sense. And I thought I'd give you just a couple of other examples of that and then have our speakers consider those as we talk. We just saw 2 amazing presentations about how AI can help us understand data, specifically about weather and climate. And all of those sort of help us understand that there's a problem with climate, and they maybe even help us understand what solutions are needed. But they don't tell us, for example, where we need to make changes within cities so that they can be as equitable as possible. The Museum of Science this week is going to be part of a group that's announced by the National Oceanographic and Atmospheric Administration that we're going to be helping to lead 30 communities around the country in heat mapping activities where people just like you can get in a vehicle, either your bike or your car, and you can drive around your city 3 times at different times of the day to help understand where the hottest and coolest spots are. And that data goes to a server farm like we saw from Michael, and then machine learning takes that and turns it into a tool, a high resolution heat map that then can be used by city planners to help cool those communities down. That's where the people come in. Because after you have data like that, you have to figure out, are we going to cool down this neighborhood or that one? What does that mean? Who's going to pay for that? How do we make sure we protect our marginalized populations, our most vulnerable neighbors, like, for example, elderly people or people with young children? The people have to be part of this. And then finally, I thought I'd just give one really interesting application of AI I learned about while I was getting ready for this, because I thought you might be interested in it. So have you ever heard of camera traps? These are things that you can do right now. You can go online and you can find where people have put networks of cameras in places where we're worried about organisms going extinct. So you can, after you're done with this, find out, for example, in the Tanzanian nature areas where there are places like elephants that are being hunted that we want to protect. And unfortunately, people just can't cover that huge amount of area. These camera traps can help us understand where the elephants are so that we know where they are. But you know what else they can do? They can track the poachers. And this brings up all sorts of questions about tracking animals and people and what that means for neighborhoods and privacy. And it helps us understand that we need people and AI coexisting in really interesting ways. And so to have a conversation about how to teach about that and how to make sure that you're all ready to be people in the world that will use AI in a way that will make the world better, I'm really excited to be joined by two very distinguished guests who are each sort of dedicated to creating impactful and inspiring resources for learners in and out of the classroom. We have Dr. Robert Parks. He's an app designer and a curriculum developer at MIT Rays, as well as the Computer Science and Artificial Intelligence Lab at MIT. Please come on up. I learned when getting ready for this that he has written several books on this topic, so I'm going to read them now. I didn't know that. And also we have Dr. Christine Cunningham, our VP of STEM Learning at the Museum of Science. Please come up. Dr. Cunningham designs a whole bunch of activities to engage people in engineering and problem-solving solution activities. And she's not going to want me to say this, but I learned over the weekend that she is a new inductee to the National Academies. This is life goals. Congratulations to Dr. Cunningham. And there's a microphone for both of you. Sorry about that. These are on. Just make sure you sort of talk right where, kind of chin level right there.
Thanks, David.
So let's get into it. And I thought it would be really interesting to just kind of build a little bit on this idea about the intersection between artificial intelligence, our environment, and this idea that it raises problems that AI can help us to solve, but really can't solve by ourselves. We need people to do that, and we need learners to consider them through our educational activities. So I was wondering if we could just have each of you quickly talk, and we'll start with Robert, about the work that you've been involved in relating to developing curriculum and activities on current science issues like the environment and artificial intelligence. What have you been up to, and what interesting things do you want to share with our audience about it?
Sure. Well, we're trying to introduce kids to the whole data pipeline. So making decisions about how to source data, making decisions about what's ethical about sourcing data and making sure it's not biased, and also figuring out how to ethically think about how it's going to be put into use. We're also thinking about making data fun. How can we make it more playful and enjoyable to collect and analyze data, and empowering to illuminate some of the topics that we're interested in, and it will really make an impact on the world. We're thinking about how to evaluate AI for its benefits and its many drawbacks, and how to create tools that will allow kids to have direct access to data and have like a personal connection that intersects with their lived experiences, their prior knowledge, and just the data that's personally meaningful, that'll make an impact to their community that they're thinking about every day.
Thanks so much. Dr. Cunningham, what kind of work are you doing on these issues, both in and out of school environments?
We focus primarily on developing resources for youth from preschool through grade 8. And related to this topic, we have a number of engineering challenges that focus on issues related to the environment. And what we try to do is have children as young as age 5 make connections between their lives and their actions and the science they're learning and ways that they can make a difference. So for instance, in 5th grade, we have kids think about, we heard about plastic pollution and how AI can help, but before you get there, we try to have kids think about plastic in their own community. So take a walk, look at all the plastic, think about where that plastic ends up, and think about how we might be able to engineer some sort of technology to remediate some of the challenges we have with plastic. Once they've had that sort of experience connected to their community, then on top of that, we may layer something related to computer science about artificial intelligence or machine learning. For our little guys, they're not necessarily using those tools yet. There's all kinds of issues there, but we can get them thinking about some of the ethical dimensions that machines need to learn, and that behind that learning, at some level, there's a human making a decision. And so how do we make sure that we're thinking about the biases that are baked into some of these models to make sure that they're reaching all populations, as you mentioned.
Thanks. Both really interesting examples of how we have to kind of think as people about how to bring these forward. What's the easiest thing about this work? Like, what just gets people energized when you bring it forward? And what's kind of the biggest challenge that you face when you bring this content to people who maybe have never explored it before, or know that they're going to be facing this technology, but really maybe haven't really applied it yet?
Well, I would say that there's just more access to data than ever before. And Dr. Conley's presentation showed how we can get this amazing view of the world instantly. So there's never been more, I guess it's cliche, there's never been more information in the world. And it's our job and our next generation's job to make sense of it and make use of it to solve some of the really major problems that we're dealing with. The hard part is the tools are a little janky right now. It's a whole roadmap of different highly technical tools that allow you to have access to this data. And I know some of these open data sets that we spoke about, that David spoke about earlier, are easy to access, but not all of them are the same way. So getting kids really close to the data with tools that perhaps they even create themselves would really help out.
And I'll pick up on that tools they create themselves piece. So I think one of the things that we hear from kids that's most inspiring is that they themselves can see themselves shaping the world that they live in. And so having first an understanding about how does this impact my life to some of the earlier presentations, and then realize that you can actually shape this world that you live in, and moving through from understanding to action, I think, is one of the things that we hear. Kids will never look at a bridge or a piece of plastic laying there on the ground again.
Thank you so much. So both of you spend a lot of time talking to educators about what they really want to have in their classrooms, talking with their students. And I'm just wondering, what are you hearing from educators and from their students too, because I know some of you actually talk to them about what kind of activities and materials they're hoping to have that might not exist yet, that will help them maneuver this frontier, this area of rich data sets that kind of blow us away and can seem really confusing but beautiful, the ethics of AI and how to address climate change. You already have built a bunch of stuff, and you're going to get a chance to play with it, I'm sure. But I'm wondering, what do people really hope they will be out there as educators maneuvering this world right now?
Well, David, one of the main things teachers are looking for are ways to get data close to kids in a way that, like Dr. Cunningham was saying, what's close to their personal interests and what connects with their lives. We're early days with these curricula, so we've got 4 new curricula that take data science and the environment on with Day of AI, and so we still need to do a lot of work doing co-design with teachers. These are sort of pilots that are going to go on for years. You're always iterating to make it better, to make it a better fit for teachers. But that said, getting the data that is allowing the students to lead their own investigations is important, and also to have it interdisciplinary. So we were talking earlier about how you're mushing together, Dr. Conley was saying, mushing together STEM in different ways. And so you get math teachers and humanities teachers talking and creating projects with kids.
I think one of the things that's common to pretty much every teacher I've ever worked with is they want to do things that are good for kids. And so figuring out, as you mentioned, that hook that gets children involved is one thing that's highly motivating. I think that's also balanced by everything they're required to do. And so thinking really carefully about how we can create these interdisciplinary activities that also align with the many requirements that teachers have to do. They have to teach to standards, they have certain constraints, they have very large classes. So how do you work with teachers, that co-creation, to make sure that they're getting resources that are able to be used? Because if you go too far, in one direction, or you get too innovative, they may not be able to use it. And if you can't use it at all, you're not making any change. So we always try to aim for, doing something innovative, but not so innovative that it falls off the ability to map.
Thanks. So this whole idea of thinking strategically so the world would be a better place, even with just one small thing you're designing. You heard from our president, Tim Ritchie, that his goal is that, people will design materials that can make all 8 billion people around the world feel included in this rapidly emerging world. And we heard Michael from the city say, we're looking at a bunch of future leaders right now, right? We're looking at people who, many of them are going to help make the world a better place and are going to grapple with these solutions. So some of you are going to have to write grants about this stuff, and you're going to have to make a logic model. A logic model is how you convince a reviewer who's looking at your idea that you're going to do it, you've thought about everything that's going to happen, and your idea is going to make the world a better place. So I'm going to ask both of you to model that for our audience. How are the things that you're doing helping you to consider your greatest hope, your big idea? What has to happen in the world in terms of education, the things that you're building in that will help these folks feel empowered to consider how to sort of grapple with these issues, whether that's environmental issues or AI? What are the things that you keep top of mind as you design these things that will help these folks feel empowered when it's their turn to be writing those logic models and teaching people in their classrooms, whether those are K through 12 or maybe some of them will be professors one day?
Well, I'm looking over to that exhibit that you were talking about earlier, making the invisible visible. And one of the most impactful research scientists in the environment, John Magnusson, in 1990, created the concept of the invisible present. There is a lag between cause and effect in our everyday lives. We can't really see what might have caused a flood or something like that because we can't see over time. And Magnusson said that environmental degradation happens in the secrecy of the invisible present. So I guess your mission and our mission is the same, to kind of demystify that and allow kids to access data so they can see a long view of things and see what led up to it, what things that could create solutions and make predictions about what they have to deal with in the future.
I'd say in terms of the logic model that drives what we do, it's the idea that we want to tap the talents of every single person in school now, in our communities. So how do we harness all the ideas, all the perspectives that every child has, and not just a subset like we have been doing in the past? So through different ideas and different perspectives, we're going to get better solutions. We know that. How do we start young enough that every child has a chance to both understand the world around them, but then also, move toward the shaping of the future? So bringing everybody to this problem and balancing both the scientific and the ethics that need to, be in constant tension, but balance so we have a better future.
Such an important point, and especially when you talk about something like climate change or artificial intelligence, when we know that the benefits may not be spread sort of equitably across our society, and with climate change, the sort of impacts of this are being felt most by many of the groups who bear the least responsibility for the problem. So how do we bring all of those ideas forward in a way that people really feel like they've got a voice and their creativity and their ideas are being included in those grand challenges that Dr. Connolly showed us? We're almost done, but just 2 quick other questions that I think will build on each other. The first one, we heard from Michael, that AI can solve a lot of these problems, but also it brings its own sustainability challenges. And so to me, that from the perspective of an educator means, how do we get people to think as systems thinkers, realizing that we have to use these tools, but we have to use them when we think about all of the trade-offs and challenges that each individual problem might raise, and that these might create challenges that are not felt equally by everyone who is downstream of their use. How do you think about that? And I'll start with Dr. Cunningham, because I know you spend a lot of time with these sort of like problem-based modules, putting people in the position of thinking about how different people have to be considered as stakeholders when we design a solution.
Yeah, so we have a model that we call our socially engaged engineering, where we try to start from very young ages and think about how we connect people to their communities, their environments, the problem to their lives. We try to encourage children to think about what are the variable impacts of the problem on different types of either people or the animals or the environment. So really thinking about, you know, who's harmed and who benefits most, and then thinking as they design solutions, you know, what are the variable impacts for those solutions. So again, who's most benefited and who's most harmed by those solutions. So sort of taking that lens and starting very, very little. Obviously a 3 or 4 year old is not balancing huge systems, but at that level, for instance, we would start to have them understand that your perspective or your needs might be different than my needs. And at age 5, that's developmentally appropriate. As they get through middle school and high school, they can balance lots of factors. So at each grade level, there's a progression of how do you sort of develop those sensitivities and encourage people to think in those kinds of ways.
Well, that's an excellent idea. We also are thinking about how to build kids' skills in weighing engineering trade-offs with benefits. And so thinking about does this AI model create enough benefit? One teacher I saw out in the world was thinking about an Energy Star rating on your browser screen to see what AI model you might be using and maybe how much environmental cost it took. So that was an interesting idea. Maybe, and there are ways that these students will come up with ideas. Our framework that we use at MIT is computational action. So using computers to address real world problems and empowering kids to do so. And a big part of the early stage of that is to look at an ethical matrix and see if your solution is really causing more problems than it's solving, and how can you mitigate the drawbacks.
Thank you so much. That idea of the triple bottom line for an engineer, are we really making the world better, not just cheaper, better, faster, you know, from the design perspective? Just one last question, and then I think you all are up for a break after all this great thinking that you've been doing. This is obviously an issue, the environment, sustainability, climate, that is most important and most impactful upon the young people that we're seeing in the audience. So on Earth Day, the Museum of Science released a poll, our first ever national poll. We asked thousands of teenagers between the ages of 13 and 17 about their perspectives about climate change and what they were hopeful about. And we did it that way because the museum, you might have seen when you walked in this morning, is in the year of the Earthshot. We have this idea that we all have to come together and find solutions that give us hope, so that wherever we are, as we heard from Dr. Connolly and Dr. Newman, there's a point where we can realize, here's what I can do. I can either do something right now with my family or in my daily life, or I can become an engineer that will solve these issues. And I'm wondering, what gives the two of you hope? What in the morning sort of makes you think, oh, this is why I'm going to go and I'm going to design a new curriculum unit, and how would you feel like you've succeeded when you have these hope moments every morning? And we can go ahead and start with you, Christine.
I'd say for me, it's the opportunity always to hear for young people and see the creativity and the different perspectives, as well as the awareness right now that this generation, your generation, has about the needs that things need to change. So it's the next generation that gives me hope.
Similar answer, I might have a little lull in my optimism between workshops with students, but as soon as you have that direct contact with folks like the New England Innovation Academy, these kids are so engaged. We were with them just a week ago today in the classroom, and they were asking tough questions and thinking about solutions in ways we'd never thought of. There's so much energy there. So those are the things that give me hope.
Well, talking to both of you has made me hopeful, and yes, seeing these really smart people, and I'm excited to go around and look at the boards afterwards. I know there's a big announcement happening after our break, so let's give our panelists a big hand. Thank you for your thoughtful answers. Thank you for being part of the conversation. Dr. Brazil, do you just want me to give them their break, or is there anything that you want me to say? Okay, so yeah, you have about 10 minutes or so just to take your brain and turn it off for a little while, and we'll start again in about 10 minutes here with an exciting announcement. Thank you.
Set up their presentations. reconvene in 1 minute. So students, can you please, come back? Because you're going to be on deck pretty soon. Welcome back. I'd like to now introduce Dr. Natalie Lau. She is the CEO of the App Inventor Foundation, and she is going to announce the Global AI Hackathon winners. Awesome.
Just 1 moment, please. Yes, we did use Google Slides, as you can see. All right, perfect. Thank you so much. So, hi everyone, my name is Natalie, and I run the App Inventor Foundation. And before that, I was actually a student at MIT for almost 10 years. I was an undergraduate, master's, and then PhD student there, working on AI and education at the MIT App Inventor Lab, which is a part of the MIT RAISE initiative. And today we're going to be celebrating the first ever Global AI Hackathon and announcing the final winners. And hopefully looking at these projects will inspire some of you to learn more about different types of AI as well. So as all of us know, the past year has been huge for AI innovation and impact. And AI education has been more important today than ever before, because we want to be able to empower everyone to be able to navigate the world they live in, participate in really important policy discussions, and also prepare for the future of work. And as Robert alluded to earlier, at MIT, we think that one of the best ways to teach AI is through computational action. So we want to get students engaged in building hands-on AI tools and AI apps that actually have an impact in real-world scenarios. So apps that can improve their lives and help their communities. So this year, we launched the Global AI Hackathon. And our goal was to get students to create apps towards 2 themes: health and wellness and climate and sustainability. And participants used the MIT App Inventor platform, which is a completely free and open source web platform for making apps that we host here at MIT. And it has 20 million users all over the world, half of whom come from the developing world. There were 4 tracks to this competition: youth team, composed of 2 to 5 team members of students under 18, youth individual, adult or mixed age team, and adult individual. And winners from each of these 4 tracks will be invited to present their projects at the MIT AI and Education Summit this July. So today, when we announce the winners, we're going to be seeing the videos from the 2 youth winners, and the videos and apps from the adult winners will be featured on social media and our website shortly thereafter. And again, this Global AI Hackathon was sponsored by DP World, hosted by the MIT Race, and organized by the App Inventor Foundation. So I wanted to share some statistics on participation for this year. We had 1,078 people participate from all over the world. The median age was 16 years old, but the youngest was 7 years old, and the most seasoned was 73 years old. So amazing range of participants. And our participants came from 91 different countries and regions, from every single continent except for Antarctica, and 55% came from the developing world. I also wanted to share the top AI tools that our projects used. These are super interesting. So perhaps unsurprisingly, 66% of projects use large language models and chatbots. And these were like ChatGPT and Gemini. 50% used image classification models, including Teachable Machine and Personal Image Classifier. And 47% used some sort of speech recognition or speech synthesis models. And as you could probably infer from these numbers, a lot of the apps that we saw use more than one type of AI. And we were really excited to see students getting really creative with multimodal AI apps. We had an amazing judging panel of 106 volunteer judges from industry, academia, nonprofits, all over the world. And we also really wanted to thank teachers from over 30 schools who took time out of one of the busiest months of the school year to volunteer and judge this hackathon. And now please put your hands together for the winners of the Global AI Hackathon. So the youth team winner is Sign Lingo. The team members are Amy Wang from Cross Timbers Middle School in Texas, Adrian Zhang from Raleigh Charter High School in North Carolina, Jonathan Shan from Poolesville High School in Maryland, and Justin Wang from Lexington High School here in Massachusetts. And as you could probably tell, they all came from different parts of the US, so they worked virtually throughout the hackathon on this project. And I think that's just one of the amazing things about a virtual hackathon and technology today. So SignLingo's mission is to foster inclusivity and bridge communication gaps for individuals who are deaf or hard of hearing through two-way translation between ASL gestures and spoken languages in voice and text. And I'll let the SignLingo team tell you a bit more about their app.
Hello everyone, I'm Amy.
I'm Adrian.
I'm Jonathan.
I am Justin.
Currently, limited tools exist for effective communication with the hearing impaired. Inspired by a playground experience with a boy using sign language, we developed SignLingo, an AI-powered app to help bridge communication gaps.
After account setup and login, you'll access our app's four main features. First, for the sign-to-text function, we use the Google Teachable Machine for data collection and AI model training to recognize and translate sign language to text or voice directly through your phone camera.
Nice to meet you.
Also, our voice-to-text feature converts spoken words into text to make smooth conversations with ASL users.
Hello, I'm Jonathan. Our app integrates a comprehensive ASL database from the ASL University. Users can simply input text to receive the corresponding ASL videos and guidance. This feature not only enhances communication with ASL users, but also fosters effective ASL learning.
We also developed an interactive AI chatbot based on ChatGPT to provide real-time assistance on ASL-related topics, from syntax to cultural insights. When you face problems in learning or communicating, our AI chatbot is here to help with advanced generative AI technology.
We invite our users to contribute to our AI database through crowdsourcing. You can easily record and upload photos or videos of your ASL gestures using our app. These uploads will be stored in the Google Firebase real-time database, continually refining our AI models. With everyone's contribution, SignLingo will grow smarter and smarter to help bridge the communication gap with the hearing impaired community. We will continue our efforts to improve the app using AI technologies.
Our goal is to break down communication barriers for the deaf community.
Together, we are creating a more inclusive future.
Thank you for your interest and support in SignLingo.
Yes. So what an amazing app. And as you could see, they use multiple types of AI. And one thing that our judges really liked is that they have this feature where you can take a video of somebody using ASL, and they actually have image classification, but they designed it in such a way that it was able to parse video very creatively as well. All right, and now the youth individual winner is VIPMOD, Vision Impaired Persons Moving Object Detector. And this was created by Maura Moore-McCune from King's Hospital School in Dublin, Ireland. And the mission of VIPMOD is to help people who are vision impaired or have other access needs to live safer and more independent lives by detecting if there are any potentially hazardous moving objects nearby. And if the app detects a car or a pedestrian, it'll display the object's name, vibrate, and give out a warning signal through text-to-speech. And this is Maura.
My name is Maura Moore-McCune, a student in the King's Hospital, Dublin. My project is called VIPMOD, Vision Impaired Persons Moving Object Detector. Approximately 250,000 people in Ireland are vision impaired. Globally, this number is over 2 billion. As a vision impaired person, I have difficulty seeing and hearing oncoming vehicles, such as electric cars or e-scooters. The focus of my project is to develop an app to detect these fast-moving objects for people who are vision impaired or with other access needs. The app also has many other potential users, such as cyclists, users of e-scooters, and horse riders.
This is my latest prototype, which uses computer vision identification to detect users on the road. I developed an AI image classification model, which I trained and incorporated into my app. I have coded the app to classify live video footage and identify a generalized car, pedestrian, or background, which is an absence of both. The app can detect vehicles against several backgrounds, such as rural roads and city streets.
My main aim in designing VIPMOD is to help visually impaired people to live a safer and more independent life, doing things that able-bodied people sometimes take for granted. Thank you so much for listening.
So this was a fantastic project, and Maura shared that she actually collected 1,000 images when training her image recognition model. So that's some really serious research there. The adult team winner is Neotalk. This team came from Kanagawa Institute of Technology in Atsugi, Japan. And the team members are Seo Yukito, Tomoya Sato, Shitara Kaede, and Dr. Takano Kosuke. Neotalk's mission is to help people who have lost communication opportunities due to online classes and remote meetings during COVID relearn how to build empathy and friendships by practicing conversations with an AI character. And these characters have customizable voices and personalities as well. So please give it up for Neotalk. The adult individual winner is Doktung, created by Haksun Kim from Gyeonggi-do, South Korea. The mission of Doktung is to support people who have difficulty seeing a doctor check their health status by taking a photo of their tongue and using the image to identify various tongue characteristics like color, abscesses, and surface texture. So please applaud Doktung. And finally, we wanted to honor our honorable mentions as well, who were selected by our judges. There were 5 honorable mentions this year. The first one is Landslide Detection and Prevention System, which was developed by a youth team in Brazil. And they created this amazing IoT device that you can put remotely to detect landslides before they happen and alert people on their phones. The second honorable mention is Allergy Ally, developed by a youth team from India. And I know I can use this right now, but it is an AI-powered allergy management companion app. Our third honorable mention is Smart Vision, developed by a youth individual from the US. And Smart Vision empowers blind and visually impaired users to explore the world with confidence. We also have Neuro Alert, which is from an adult team from Canada. And it's an AI-powered companion for rapid stroke symptom detection and emergency response. And our final honorable mention is Moya Moya, which was an adult individual submission from Japan. And through dialogue with Moya Moya, users can dig deeper into their unverbalized feelings and deal with them in a positive way. So thank you so much for attending this event and participating in the Global AI Hackathon. And if you're interested in meeting these projects and creators in person, please come to the MIT AI and Education Summit this July. Registration is now open. And now I'd like to introduce Robert Parks from the MIT App Inventor education team.
Thank you very much, Natalie. What an exciting announcement of great AI-powered apps winning the event. I'm going to just tee up kind of what we prepared the New England Innovation Academy students with just 1 week ago, and you'll be blown away by how much thinking they did in just 1 week. We got 6 teams, and I hope after I just give a little bit of lead-in, we can go to visit each booth and find out what amazing ideas kids came up with. This is a typical workflow for us where we're starting with an example curriculum, and we hope the kids will use it and futz around with it and see its limits and push back on it. And then the next step would be they create their own apps, completely fresh apps that will address a problem that they're concerned about. So we're using this as a use case with NEIA, and we were there just a week ago, and we have also tested this with the Boston Public Schools and with the Technovation Girls program. And our next, it's one of the curricula that's one of the 4 in Day of AI that teachers can access right now on the Day of AI website that have to do with data science in the environment. So, who here is familiar with lake ice being from New England? Right? We love to jump around on it, skate. We talked with the students just a week ago about how it's important for food production. It's an aesthetic thing, but it's also crucial for the ecosystem of a lake. For New England lakes to have an annual freeze over. It's part of their ecological process. A couple of years ago, some very important groundbreaking academic papers started to come out about the loss of lake ice across the northern hemisphere. These papers showed that there's been a decline in the last 50 years in lake ice, and cite a lot of data. And so we were thinking about ways to make that data available to students. A lot of this is a little bit difficult to access. It may be in a public database that has too much data, or data with anomalies in it that you have to remove before you can really analyze it. So we have kids making apps that will visualize, analyze, clean, and then make predictions based on that data. So we're using App Inventor, as Natalie was talking about, a way that kids learn how to make their own tools. So they're making a tool as a practice using this data. Spreadsheet data is really difficult to kind of understand. We've got a lot of numbers. We don't know if there's a trend. We've got, this is actual data from those scientific research papers about the duration of lake ice. And you'll see this funny little metric on the third column there is duration. It's for hundreds of years, people have been going out to lakes and finding out when they freeze and then when they thaw in the spring and figuring out the total number of days per year that the lakes are frozen, and that's called duration. People have been doing it since 1443 when Shinto priests went to Lake Suwa in Japan to see when the lake froze and unfroze because it's important to their culture. So the first thing you might want to do is to bring it into an app to visualize it, so you could share it with your users, make arguments to people about the status of the lake ice. But when you visualize it just as a visualization, there's a lot of variability in this duration data. This is the number of days, again, that the lake was frozen each year from 1955. And it jumps all over the place. The kids from the school have already heard this, but we need tools to start to make sense of it. Some of the more sophisticated statistical tools that are often not available to kids could be easily introduced into middle school and high school curricula. So we need tools to make predictions, and one of them is a model that you could apply over the data. So now we have a much better sense of where this data is going. We see that lake ice duration data is sneaking down a little bit since 1955, and the average winter temperatures around the lake on the bottom chart, they're sneaking up since 1955, and you can see a correlation between years when there's a little higher temperatures, a little warmer winter, and you can see it correlate with years when there's less ice for the year. And with a model called line of best fit, you get a couple of numbers. So you get a slope here. M helps us understand that maybe every 10 years there's going to be a 6-day loss of ice cover in this particular lake in Iowa. And you also see a number called R that you could introduce to kids earlier on before they do all the math behind it. But it's the confidence level of how much data is here and what can you really say about it. Luckily, the research scientists who use this data look at a lot more lakes, and so they see that although the confidence level in just a small data set of this lake is pretty low, the R is a pretty low number. The combination of many lakes kind of proves out this data. So it's a good conversation about ethics and bias. Maybe you're having a too small data set that you would use to feed an AI system or something like that. And so you would talk about how you'd need a lot more data because we've analyzed it and we've seen that the confidence is pretty low. We need more lakes to make our argument. But for now, we can look at a visualization of a very important part of this data is when will there be no ice on the lake? And so Sharma Shapna, the doctor who is putting together the large-scale research on this, is seeing some pretty difficult truths about the Great Lakes in the United States are possibly going to be without any ice at all in 2060. So basically 35 years from now, no ice at all. This lake has a much better prognosis. We're seeing 2280 as a date when we're probably not going to see ice unless current greenhouse gas emissions are curbed. This is all using our current situation that we're in. But going along as we are, we're going to see 2280 complete loss of ice on this particular lake. And once we've done the math in terms of getting a good line of best fit, this model here, we've got some important numbers like the slope, and we've got the date when the ice may cross the x-intercept, then we can feed it into AI. So that's an important step, and you're going to see that with all of these projects, that the AI chatbot, when prompted well, can give you a lot of good context and a lot of analysis. You can compare it against your statistical and mathematical predictions. So we're seeing that. That's a pretty dire visualization. And we're also seeing some really good analysis from the AI. Look at this, how it's kind of confirming our prediction with traditional math, and it's also giving us some context about the detrimental effects to the ecosystem. And we could further prompt that to give more data about that and more detail. This is what it looks like in the app building system that we use. It's what we taught a week ago, and I'm sure the kids have already outstripped what we taught them and gone way beyond, is prompt engineering. So we're telling the AI what we want, what kind of information we want, how we want it, and we're also dumping the chart data from the app right into the AI chatbot, and it knows what to do with tabular data. So it's a great way of providing additional analysis to public data sets. And with that, I want to encourage you all to get up and visit these amazing presentations that students have created. Yeah? Excellent. Okay. So Salim is telling me that we're going to have a chance to hear from New England Innovation Academy. It's a school from 7 to 12 grade kids in Marlborough, Massachusetts. And I want to thank you very much for listening today and also checking out what these kids have created. We're going to hear from Langston.
Hi, my name is Langston Reed. I'm an 11th grade student entrepreneur at the New England Innovation Academy. And I'm going to tell you a little bit about NIA, right? So NIA is a day and boarding school in Marlborough, Massachusetts. It has over 100 students. And what makes NIA different than other schools is we focus on 3 pillars: human-centered design, innovation, and entrepreneurship. I think one key reason why I came to NIA was because I was asked a question actually similarly over here, which was, you know, what's your biggest concern about AI? What's your biggest concern about the future? My response was, the best way to predict the future is to create it. And the reason why I came to NIA is, as a student entrepreneur, I wanted to be given the resources, the knowledge, the teachers, the support to be able to create my own reality and be able to improve my environment and my community. So I, as a student, came to NIA for that reason, and NIA is incredible and has been so supportive in me, and this is just one great opportunity on how they've been giving us the resources and knowledge and support and foundation to change the world around us in a positive light. So thank you, and that's NIA.
All right, hi, I'm Vishnu. I'm an 8th grade innovator at New England Innovation Academy, and I'll talk a little bit more about the workshop that Robert was just talking about from sort of a student's perspective. So around 20 students were invited to join this workshop. We had to submit an application, and it was really wonderful to see staff from both MIT Raise and also the team from App Inventor sort of come and really guide us on how to use the tool of App Inventor to do this statistical analysis using artificial intelligence to look into these issues like sustainability and climate change, right? And that we were really excited to have that opportunity to be able to use these tools and block-based programming to, you know, have an outlet of what we want to do. And like Langston's saying, shaping the future is the best way of predicting the future. In a 3-hour workshop, we were introduced to App Inventor, we were given a basic tutorial of how to use it, and then we were pretty much from there allowed to explore how to use that block-based programming environment for our own projects. And I'm just going to pass it to Simon here, who's going to talk a little bit more about that.
Yes. Thank you, Vishnu. My name is Simon. I'm a 9th grade student at New England Innovation Academy. So after the workshop, we were assigned with, in groups of 7, no, there were 7 groups, sorry. We were assigned in groups of 3 to 4. There were 7 teams, and basically we were to design an app that combats climate change using AI. So we had a full week to work on that project, and as you can see, there are posters up all around, and I urge everyone here to go check those out.
So please enjoy the presentations by the students. Awesome.